All right, here we go. We're going to start the fall 2019 semester exam review. So let's make sure we have everything we need to help you get ready for the test. Are you ready? The first 4 questions, you need to know some things about planes and lines and points and things like that. So name a point on line N. Keep in mind, line N is this one. When you see the lowercase letter, that's when you use one letter for a line. Okay, everything on that line is part of that. So any point on there, so A or D. That's pretty easy, right? Now a segment requires 2 points. Remember that. Keep in mind 2 points should be mentioned here, like AE or EA. You could choose either one. Okay, array. Okay, whatever they say is the endpoint, that should be the first point you list. Okay, so that's the first letter. So like endpoint C, I would say CA or CB. Alright, so let's get to number 4. Number 4 says, name 3 collinear points. So you should know that collinear means on the same line. Non-collinear, not on the same line. So BAC could be considered 3 collinear points because they're all on the same line. Yo, I get it. Alright, number 5. Number 5, Okay, so number 5 is harder than what I would give you probably, but let's see here. Alright, so basically I drew out what they said. F is between E and G. So I just drew a point that's between E and G. Now notice that does not mean they're equal. So it's just in between. So that means EG, which is the total, is equal to EF plus FG. In other words, 2 small parts. And if I want to find one of the small parts, I subtract it from the total. Okay? So in this case, I'm going to subtract these 2 and go from there. And that would give me 3x plus 10. Now, maybe what I would do for y'all is give y'all some numbers. Like, let's say EG was 16. And FG was, no, let's say EG was, or EF was, like, let's say 12. Then, because this is the total, and this is a part, you need to subtract those 2, and that would give you that FG is 4. Okay? So that's something I would probably give you. Alright, so let's look at number 6. Linear pair. What is a linear pair? Okay, that is 2 angles that add up to 180 and are next to each other. So remember, but it's only 2 angles, and they need to equal 180. Okay? So in this case, like if I see here, like I could look at problem like 1, 2, 3, 4, and okay, that's 3 angles, so I'm not going to go with that. But if I look at 4 and 5, I got it. Wow, that just kind of came out of nowhere. Alright, so keep in mind that adjacent means they got to be next to each other, but there's only 2 angles that make up that 180 degrees. So in this case, these 2 are those. Okay? Classify acute right obtuse. That should be fairly easy. Obviously, you can tell that this one's going to be acute. Number 7, B. Let's call it that. The one that says Z is the interior of WXY. The measurement of WXZ is 110. ZXY is 20. What is WXY? Okay, so here's W, X. Whoops. Let's try that again. Okay, here's W, here's X, and here's Y. Z is somewhere in between that. And they say that WXZ is 110. ZXY is 20. So what is WXY? Well, just add the 2, and then you would get 130 degrees. Fairly simple. Alright, midpoint. A midpoint formula is add the x's divided by 2, add the y's divided by 2. If I give you the midpoint, you need to multiply the midpoint by 2, and then subtract the x coordinate that they give you. Okay? So, like on number 8, you're going to say -7 plus 5 divided by 2, and 3 plus 9 divided by 2 to get -1/6. But on number 9, I have no idea what I was doing there. Okay, so number 9, what I did is this. I took the midpoint coordinate, -1 and 5, multiplied that by 2 to get -2 and 10. I'm going to use those numbers, and I'm going to subtract them by the x's. So -2 minus a -5 gives me 3, and then 10 minus 2 gives me 8. Okay, and that's it. That should be it. That right there should give you 3, 8. That would give you the point. That would be midpoint. Now, you want to go the long way and be multiple choice. I mean, you could try your different answer choices, plug them into this formula, and see if they give you the right answer. That just seems like a lot of extra work for me. If you have these written into your formula sheet, it should be easy. So if you have this in your formula sheet, it should make it easy. Alright, this is formula for like number 10. That's the formula. Subtract the x's squared plus subtract the y squared. Take the square root of that. So like if I look at number 10, I would say, like again, what I always do is I always start off like this. La 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 la. Okay, my x's are -4 and 3. My y's are -3 and 5. And then I can type that into the calculator, press enter, and I should get my answer. And I get an answer of 10.63. So there you go with that. And that is that. Number 11. We got to find a pattern. You should be able to find a pattern. Let's see here. -1, 0, 3, 8, 15. I mean, just basically, you're trying to tell the pattern. Like, let's see here. This one changes by 1, then 3, then 5, then 7. What could the pattern be? Could the next one be 9? Could it be 9? I think it could be 9. And after that, it would have been 11. And you get the idea. Okay, so that one should be fairly easy. Okay. I'm not sure how much we have of these, but let's see. How can I show that the difference, show something is false by finding a counterexample? The difference of two odd numbers is a prime number. Okay, so what does that say? It says difference of two odd numbers. Let's say 19 and 17. Or let's say, okay, 19 and 17, that's 2. Well, that is a prime number. So let's try a different one. Let's try 19 and 15. That's the difference of two odd numbers. That gives me 4. 4 is not a prime number. So here is a counterexample. So something like that. You're looking for something that would disprove whatever the conjecture is. Okay? In a multiple choice, that should be fairly easy. So kind of keep that in mind. Write the inverse of the conditional statement. Let's look at that. Okay, so before I get to number 13 and 14 and stuff like that, let's look at this. A conditional statement says, like, if P, then Q, or P then Q, whatever. Converse would be Q, then P, if Q, then P type of thing. Inverse would be not P, not Q, and then the contrapositive would be not Q. Remember, this means the little squiggly line here means not P. Okay, that means not. All right, so if you go to number 13 and write the inverse of that statement, the simplest thing to do is it says if the sum of two whole numbers is even, then both addends are even. Huh? What? So if I need to stick in a not there. So if the sum of two whole numbers is not even. Oh, is not even. And again, I could put in there odd, because not even is odd. I mean, y'all should understand that. Never mind. Anyways, then both addends, that means the numbers you're adding together, are not even. So again, maybe something, actually that one should be more not even, because you could be saying one's odd, one's even, that type of thing. But we'll go with something like that. So you look for something like that. I try to make that a little bit obvious on types of tests like this, because I don't need to make it difficult, but there you go. Write the converse, number 14. Okay, so converse again, going back here. Converse is just switching things around. So if it says two angles are congruent, then they have the same measure. If two angles have the same measure, so you switch it around, have same measure, then they are congruent. That's it. That's all you got to do. Okay? And that's it. So kind of go with that. All right, let's look at number 15. Shall we? We shall. This is like the fastest I've gone through like a review. Interesting. If the area of a circle is numerically equal to the circumference of the circle, then twice the radius is equal to the square of the radius. If twice the radius is equal to square, then the diameter. Draw a conclusion from the given information. Okay. Okay, I re-looked at, say, the semester exam, and I would tell you 15 and 16 are not going to be on the test, but I would make sure you do know how to identify hypothesis and conclusion. That should be fairly easy. Remember, the hypothesis is the one in front of the if, and conclusion is after the then. Okay? And if you were looking on number 15, if the area of a circle is numerically equal to the circumference, that's a hypothesis. Then twice the radius is equal to the square of the radius. That's a conclusion. If twice the radius is equal to the square of the radius, that's a hypothesis. Then the diameter is equal to the square of the radius. Conclusion. So, something like that lines, you should be fine. All right. You should know your reflexive property. Symmetric property. Transitive property. Keep in mind, anything reflexive means is equal to itself. So like A is equal to A. Symmetric property is A is equal to B. Then B is equal to A. Transitive says like A is equal to B. B is equal to C. Then A is equal to C. Something like that along those lines. So make sure like that. You can put that there. So on number 17, again, what would that be? Angle A is congruent to itself. Number 18, if ABC is congruent, that should be, say, congruent to XYZ. This is a horrible copy. Then angle XYZ is congruent to angle ABC. And then on number 19, use the transitive property. If AB is congruent to CD, CD is congruent to EF, then AB is congruent to EF. Okay? And that's all that is. I mean, if you need me to explain that further, I can, and then we can go from there. Alright, so that kind of gets us to a certain area. Number 20, I think I will worry about later. And we'll go from there. I'm going to look over the test a little bit more, make sure if there's anything else I need to add in here, I will add. But for now, I will go ahead and stop there, weirdly enough. So, we'll go ahead and stop there for part 1 and say that's it for part 1. And y'all take care. Thank you so much for your time.